Good morning. So this is section 5.1, using fundamental identities. We're going to go back and revisit these identities that we've talked about in the past. And you can find these on the unit circle sheet that I gave you, down about halfway down the left side column. And we're going to be reminding ourselves of things like what the cotangent of sine theta times sine theta simplifies to. And we will look back and remember that cotangent has a quotient identity of cosine over sine. And we'll leave sine theta alone because these can cancel out and it would just be cosine. We're going to see things like where we use the Pythagorean identities. And we might have to rewrite them, like we might need to know what sine squared theta minus 1 is. So we would rewrite this. We would move the 1 over here by the sine squared and rearrange the cosine squared over there. So we'd write sine squared theta minus 1, and if I kick the cosine to the other side, is equal to that. So we could replace this with negative cosine squared theta. So we're going to work with our identities a little bit in factoring. So I'm going to start with example 2. It says simplify. And I'm going to say simplify by factoring. So I think you should take notes on this with me in your notebook, because this is one of those topics where you will want to look back when you see something that's kind of similar and see how we did it. So first off, let's just talk about the fact that this is two separate terms. This is a term and this is a term. Terms are separated by addition and subtraction symbols. So two separate terms. If I'm going to factor, look for the GCF in these two terms, and they both have sine x. So we're going to factor sine x out and say what's left. Well, in the first term, cosine squared x is left, and the second term of 1 is left. And this makes me think of the Pythagorean identity. So if we rewrite this, if we move the 1 over and kick the sine to the other side, we get cosine squared x minus 1 is sine squared x. So we can replace cosine squared x in our formula with sine squared x. So let's replace this with what it's equal to. And this is multiplying like bases, just like this is. When you multiply like bases, you add exponents. This is just a little example. So when we multiply these signs together, we add their powers. All right, let's see example 3. Example 3 says factor. A part. What if we have secant squared theta minus 1? Well, hopefully that reminds you of a difference of squares, which we'll do as a minus ba plus b. So this is going to factor as square root of secant squared theta is secant theta minus 1 and secant theta plus 1. Secant squared theta is secant theta squared, and 1 is 1 squared. So we just use those as our a and our b. B part, what if you have 4 tangent squared theta plus a tangent theta minus 3? Well, you might think that's quadratic like. Well, it is quadratic actually. It's just our variable term is tangent theta, not just theta, or not just x squared. So we could do that little u substitution or a little y substitution like we did with logarithms. And you always let it be the x term for bx. It's always that. So we could rewrite this as 4y squared plus y minus 3. I'll do x method with it. A times c at the top, b at the bottom. Factors that multiply to 12 and add to 1. And since a is not just a 1, we've got to divide both of these by 4. So you get y minus 3/4 and y plus 1, because this divides and gives you a 1. And then I'd like that y moved up, the 4 moved up here as 4y minus 3, y plus 1. And then lastly, we got to plug back in for y. So 4 tangent theta minus 3 and tangent theta plus 1. Okay, let's see, one last one here. Actually, that is it for today. I'm saving the others for us. So give these a try. And the very first problems in the homework are just working with the identities. So good luck. And you can come and see me Wednesday at lunch if you have any trouble.